So welcome everybody. Um, what we're hoping is going to happen is that this is going to be more of a dialogue, a conversation. I'm David Saah. That's Karis Tenneson. That's Kale Markert. And what we're going to do today is we're going to talk to you guys about SERVIR. And the way we're going to try to do this is we're going to give you an overview of what SERVIR actually is, right? What it is, what the purpose of it is, how you can get engaged with the program. And then we have a whole bunch of tools that we built on top of Google Earth Engine technologies, right? And in those tools, we're going to talk about what those use cases actually are. You know, what is the actual use case? And more importantly, if you like that use case and you like that tool, we're going to give you the links to the tools themselves with one caveat, that if you can make it better, you'll share that back with us. So we have GitHub repositories. We're going to go through a series, I think, of 10 or 11 different examples of tools that you could actually grab and download. And then after that, what we're going to do is that there's two tools that we co-developed with some partners. One with FAO. FAO folk, raise your hand. Alfonso over there. We're going to talk about one that's called Collect Earth Online, and then we're going to take a deep dive into our regional land cover monitoring system, which is also part of our hackathon. And we had a pretty amazing showing last night. We had some very dedicated individuals show up, and if you're interested in participating, we're going to continue that on today. Any questions? Hearing none, I'm moving forward. So, what is SERVIR? You guys heard me talk about this briefly during some of the previous events. SERVIR is a program between NASA and USAID, and the idea is to bring space-based technologies down to village-level decision-making in a way where you're building capacity in a local context, right? We don't want to go in there and build a tool or a data product and just throw it at a local government organization and say, use it. We want to figure out what folks are needing and wanting, and co-developing something that they could actually pull, use, and integrate into their daily activities, daily lives. Sounds pretty cool, huh? There's a whole wide variety of services that we work in. There's a lot of interesting things that we heard at this conference. People are doing amazing stuff with like wildlife and energy and all kinds of really neat things. What we try to do is we're trying to focus into like 4 main service areas, and they're big and they're broad, and you can encompass a lot of things inside of them, but we're trying to tailor them to these main 4 that you can see on the screen. One is agriculture and food security. Next one is land cover mapping. That's one of the ones we're going to take a deep dive in today. There's a waters and disasters program, a lot of near real-time flood mapping, where water bodies are actually located. So if you're interested in that sort of stuff, we have some tools. We'll show you about that, some of that stuff today. And then there's water and disasters. And then there's also a weather and climate part to this whole study as well. And there's some, I think we have one example on that, maybe 2 examples on that we might show. Okay. So where do we currently work? Right now we have 4 main hubs. One is in the severe Mekong region. That's the one that I spend a lot of my time in, though we all help with all of them. There's one in the Himalaya Hindu Kush region that's active. There's one in East Africa and West Africa, and you can see on the slides the countries that are involved in both of those. There's a new one that's being established in the Amazonia region, which we're, everyone very, very excited about. And then there was one in Central America that has the potential of being revived. So that's the footprint of where we work. You can see it's a relatively large footprint where we're working with a lot of local individuals. So there's places where you want to partner with, or you have projects in any of these countries or any of these regions and you want to collaborate with something, please see us afterwards. We're more than eager to talk to you and work with you on stuff. I know I see a bunch of friendly faces in here where this has been done before. Always open to new relationships and new collaborations. Now, the hard part of this whole thing is you have this great scientific community and you got these big user needs, and we're trying to build a bridge between the two, and that can be very difficult sometimes, right? Sometimes there's miscommunication in technology needs, sometimes there's miscommunication in capacity needs, sometimes there's miscommunication in terms of just basic access. And the basis of the SERVIR program is to figure out how to build that bridge. And since it's a NASA USAID funded program, or USAID NASA funded program, you can kind of see where you have 2 agencies trying to bridge their strengths together to create something that is long lasting and durable, right? So on the science side, I'm sure everyone in this room, just being here at this conference, knows about a ton of the different Earth observations that are actually out there. There's tons of satellites that are out there collecting all kinds of different information. There's new satellites and new technologies being launched all the time. Sorry I don't have the Sentinel systems up here. It would be nice to get a graphic where we have both of them together. That would look really cool. Maybe for the next presentation we could do something like that. And all these, you guys know this, all these sensors collect a whole wide variety of information, Earth observations, right? And those Earth observations that can get converted into a wide variety of measures, whether it's shifts in vegetation concentrations or ocean chlorophyll concentrations. And this information is great, and it's usually not very accessible. It's only accessible to a select few individuals who actually really know how to take this data and to turn it into something that's meaningful. And what's going to be more complicated as we start seeing new sensors come up, this information is going to start to come down faster, right? There's more of it, and the temporal latency is going to get shorter. There's more information that's going to come. How do you take all of this type of stuff, right, that's growing at a breakneck pace and distill it down to a place where you can get to that other side of the bridge and give it to a user, right? So there's a lot of remote sensors in this room. We're just trying to keep up with the emerging technology, the emerging data streams. We're looking one way, and what I'm encouraging us to do is turn around and every now and then look back at our end users and understand how we need to digest some of this stuff back down to things that they could actually use and need. And so in order to do a lot of this stuff, what we do is we leverage a lot of the expertise and relationships that we have around the country. Here's an example of some of the partnerships that the SERVIR program has with existing projects. There's these, NASA puts out these solicitations, these calls, they're applied science technology calls, and this is one way scientists who actually understand how to digest all that information could engage with the program, engage with that data, digest it to a point where it's a usable product, and push it back into our hubs. And you can see there's a whole wide variety of institutions here. We're in Europe. Europe is beautiful. We have collaborations with Deltaris, Delft, ITC, a wide variety of organizations, and it's growing. This isn't just a US-based thing. Big international global collaboration. That's what we're thinking about. And if you are interested in this, take a picture of this, or we'll make these slides available. There's a solicitation that's going to be going out. We can encourage you, please look into this. Think about this. If you do want to get engaged, here's one place where you could actually actively engage with us, okay? That's on the science side. Now on the user side, how do we deal with the user side of the equation, right? This is a demand-driven program, and so what we're really trying to drive towards is that bottom corner over there, is that impact, right? It's great that we could do a cool map, it's great that we could build a killer app, but if it doesn't change something on the ground, it's not as cool as it could be, right? It could be much better, right? And so what we've done is we've developed a whole service delivery framework for this, right? And so the first step of this whole thing is to really figure out what the collaborations are. Who are those stakeholders? Do stakeholder mapping. Figure out what the whole wide variety of needs are. Identify what their developing challenges are, and get a good understanding of what that whole sphere looks like. The second step on this thing is to, once you actually understand what the problem space is and who the users are, is to develop a plan with them. And when you're developing a plan, the idea is not to bring in the best technology out there all the time. The idea is to give them the information they need to solve their problem, right? And then the last step is, it's really focused on the delivery. Once you actually understand who the users are, what their problem is, how to actually come up with a solution, what's the delivery package? And the delivery package could be a wide variety of ways, and we'll talk about some of them in the next slide, but that's kind of the framework here, right? So it's not always the best, coolest things. Mindset in the SERVIR program is, how do we solve a problem for a user where they could solve their own problems in the future, right? Sounds easy, sounds cool. It's very difficult to actually do. In the Mekong region, what we do, actually in all the different regions, again, using the demand-driven services, we have a place for folks to actually request for technical assistance, right? So this is the first entry point. we do these conferences, we do these workshops where people ask for different sorts of things, but we have like a passive technical assistance need. And you could request new data sets or customized data sets. You could request a new tool, customized tool, capacity building or training. This is where a lot of Earth Engine requests actually come in over here, or technical advice or consulting. So a lot of times what will happen if somebody comes in with a technical request for something like, hey, listen, in northern Myanmar, there's a whole bunch of issues over there, and we're worried about landslides, and we need somebody who's an expert in landslides to help give us some information. Once we get that request within the hub, we push it back to the NASA network, and we say, who out there actually has expertise or a tool that's ready to go, shelf ready to go? Work with them, deploy it back to where that user made that request, and now we have an impact, a really quick impact, and that mechanism is set up for that, right? The Mekong region, what we also did, and they do this in all the different regions, is we start off with a needs assessment, where you go to all the major countries, you look at all their priority areas, you look at, we try to get this information using a wide variety of sources, and for this first one that we did about 4 years ago, we consulted with about 300 people in a wide variety of arenas to figure out what they actually wanted. And in that area, with the four main things that came up over and over and over again that were consistent with the stuff that we actually work in, were land cover mapping support, and we're going to talk a lot more about that later, early warning systems specifically for droughts and crops, water resource management, and crop yield forecasting. Those are the four main ones. And again, going back to what we talked about just a few seconds ago, we take those sorts of requests, we go to our NASA networks and those partnerships, and we start building co-development relationships. And here's 4 examples here. I'm not going to go through them because we're going to run out of time. But what we do is we basically pair up scientists that we know have deep expertise with this stuff with a local department or a local group of individuals who have a deep need for this stuff and the capacity to take it up. We pair them together and we start co-developing those solutions for them. And we have one example for all the different regions for all the major service areas. Sounds pretty cool, huh?
So are these all people that apply for that NASA server?
Yeah, so these folks all here all have they're part of the last round of the Applied Science Technology grants, right? And so that's the counterpart side. Did you want to add anything to that? Nope. All right. So by the numbers, what have we been able to do so far, right? And these numbers are a little stale, but you get an idea. We've been able to train over 3,500 people. We've been able to work with over 260 institutions. There's well over 400 decision makers and scientists that are participating in existing technical exchanges. And these are when we put these numbers up, these are active engagements. So these are active things that are happening globally. So it's a pretty big, broad network. In terms of tools, 73 active tools have been developed and growing, and so we're going to share some of them with you, and we give these tools out. They're all open source by definition. You get them, build on them, which is a unique thing to SERVIR. Over 1.5 million map elements were interacted with, and I'm not quite sure how they got that statistic, but it sounds neat, so I'm going to say it. 27 satellites have been used, including most of the NASA constellation and a lot of the European constellation, which is, we're really, really excited about. We want to grow with, and a whole wide variety of collaborations. So what I want to do now is I know you guys aren't here just to hear about the big, broad SERVIR, but want to see some of the tools that we have and to see where you could actually potentially engage. I'm going to ask Kale to come up if you can. And let's start going through some of the examples. And what I'd like you to do, and ask questions if you can, I'm going to stick you on the spot here, is to go through what the demand was, right? How we came up with a solution, what the solution looks like, and how you can access it. Is that all right?
Perfect.
All right.
All right. Good morning. As David mentioned, I'm Kel. So I work at the NASA Marshall Space Flight Center, and part of my job is helping coordinate across that global network and working with the end users and the science teams to make sure that we speak well together. So if we're building a scientific algorithm or there's a specific need, how can we tailor the algorithm or tailor a information technology package that meets those needs? And so it's kind of like bridging that gap. So that, I guess that image of that bridge with no center is my job. Okay, so I'm going to walk you through a couple examples here. So I'm going to, again, talk about what was the need and how we actually delivered a service for that need. In this particular case, we had, so Myanmar does not have the capacity to do any kind of flood hazard mapping. You know, in the US, we do a lot of modeling. We have a lot of high resolution data. So we can build these areas of flood risk and everything. So they don't have that capacity. So what we did is we leveraged data on Google Earth Engine and the extensive historical data sets and then the JRC data sets that were created. And we delivered this tool to build a historical flood analysis. So that way our stakeholders in the region can view what areas were most observed with water. And then we have a couple other overlays and everything where you can overlay world population data, you can do some spatial and temporal filtering, and they can more or less get an idea of where there historically has been floods. And this is being used to prioritize areas for resources in emergency situations, and also to help prioritize where they should build these shelters to help flood relief.
Okay, Cal, before you leave, can you describe what those two links are on the bottom?
Okay. Thank you. So the top link over there is the actual link to the tool. So you can go on there. This is an active tool. You can go, you can play around, turn map layers on and off. This is built on Earth Engine. So we're just calling Earth Engine on the back end, and it's delivering those layers. And we have a couple. So if you went to that UI widget thing or the session, this is basically a little bit more top level than that. And so that's the first link, and the second link is a link to the GitHub page. So again, we work completely open source. Anything we produce, we post on GitHub. We also have in development tools and everything. So if you go on our GitHub page, you can see what we're actively working on. If you have something that fits your needs and you want to pull that, it's not directly finished yet, but if you want to add to it, please do so. So for each tool we're going through, we'll give you those links. Okay, this next tool is a very similar use case, where our stakeholders needed to understand what are these dynamics of surface water in the region. The first case was specifically for Myanmar. In this case, this was a more broad Mekong region tool. So we partnered with Deltaris, who all knows Genna. So he helped us out with this one. And so this is using one of his algorithms that looks at these dense time series of Landsat data, and we're able to produce these surface water maps for these really dense cloud prone regions. And again, this is the web interface and everything. And this was actively used in a drought situation in 2016 in Cambodia. So they needed to understand where there actually was water in these remote locations, because most of these villages didn't know where the water was. So we were able to give them a heads up display on where there's water and where they can go get some. And again, there's the link to the tool. It's active. And of course, the code on GitHub. So this is a very interesting project that we are actively working on. So it's still in development, but we're going to walk you through it. So this is a use case in West Africa, in Senegal, in the Furlough ecological region. So there's this whole culture on pastoralist, pastoral farming in the region, and what they do is they just basically guide their herds to specific watering holes that they know of. A lot of times they guide their herds and there's not water because it's a pretty arid region. There's large evapotranspiration, so these are ephemeral ponds. Also, there's this issue of water quality. Who wants to drink that water in that image? It's pretty bad. No, I wouldn't want to do that. And so this has implications for food security, water security. There's rival tribes that are clashing when they're trying to find these waters. So what we're doing is we're working with Veterinarians Without Borders and delivering this simple web interface where they can historically view water in time for those specific ponds. And then we also are providing these simple forecasts. So we've implemented a very simple water balance model on Earth Engine that's pulling the GFS data, and we're able to give them a heads-up display on where water will be in the future. So if they have to take some time, 3 days to get to the specific pond, then they actually know that there is going to be water. And again, so this is live, and we're actively working on that. We're fine-tuning our algorithms. So who went to the TensorFlow session? Yeah, I want to use some of that stuff to find more ponds. That was pretty cool. So that's on the next step on things. If you guys have any questions, just raise your hand or blur it out. That's fine.
What imagery are you using there?
So we're using Landsat and Sentinel. So we use some NASA algorithms to harmonize Landsat and Sentinel on Earth Engine. And so right now we're doing a simple harmonization. We have a grad student that's looking at optimal water detection techniques in these regions, and we're planning to scale it up after we've done this pilot area to all of West Africa.
And so how do you plan to provide this support to the farmers, or is it like a website, or?
Yeah, so this is a website. It's actually mobile friendly, so farmers can go on there. But what we're actually doing is partnering with Veterinarians Without Borders. They're the ones that are looking at this interface, and they're providing radio. They're giving radio updates and SMS messages to the farmers in the region to say, okay, this is where you should be going to versus this area. So we're not actively interfacing with the beneficiaries, but we're working with these stakeholders to actually reach the impact on the ground. Okay, this next tool, this was focused in the Mekong region. So the Mekong is under large development, and there's a lot of dams being built, and there's this big issue of sedimentation in the region. So there's a need to monitor the surface sediment dynamics in the region, but the current monitoring systems that they have are at monthly time scales, and it's point-based, so there's not much. Sometimes they're missing some things. So what we did is we worked with the Mekong River Commission, who's taking these samples, and we developed some simple empirical algorithms, and we just deployed this on Earth Engine. There's this nice paper up there, so again, this is all open source, everything's available. So you guys can go on the website, pull the code, look at the data, and so our stakeholders are able to pick a region of interest and just get a nice time series without having to worry about doing all the satellite processing or anything like that. Oops, I think we put these backwards. This next tool is focused on monitoring an impact. So a lot of times in our line of work, we're developing these tools, we're delivering them, we're working with stakeholders, but we want to actually understand how we're making an impact on the ground. And so we designed this tool to really focus on if we're providing information to make a decision, to make a change on ground, how's that actually affecting things? And so in this case, this was partnering with the Vietnam Force and Delta program from USAID, and they were what specifically were they doing on the ground? They
had so a lot of the USAID programs they want to monitor their sustainable landscapes programs, and they spend a lot of money within watersheds, and the question was, is it working? And one of the ways that they wanted to observe it, one of the ways that they were doing it beforehand, is they had a whole wide variety of analysts that were basically downloading NDVI maps for 2 places and saying, hey, is NDVI stabilized or is it going down? And we walked them through what they were actually trying to do. And for those of you who are familiar with BACI designs, before, after, impact control sorts of studies, that's what they were trying to do without actually calling it out. So we helped them call out their analytical process. We built a tool that was consistent for them and that they could use in their annual monitoring. And what happened was that everybody started asking for this tool, so we just grew it out a little bit.
Yep. Thank you. And so now the next step after working with the Vietnam Forest and Delta is we just scaled this out. And so now this is a global tool where our stakeholders, largely USAID, can go and say, okay, we actually went to this area, changed or implemented some policy or tried to change on the ground. And then
What's the lowest resolution for this? Is it Turkey?
so this is using the 500 meter MODIS EVI data set. We do a lot of the quality controlling flags and everything to make sure that we're not picking up any changes in water or what have you. And so yeah, that's why you're seeing a little bit of masking up at the top and everything. But yeah, it's global at this point. And so again, paper, and we have our code available. So if you guys want to take this and make a custom application, please feel free to do so. And so the idea here is that you're able to define a baseline time period using the before periods, and you're able to define when after there was intervention in place, and then the control region and intervention region, and you're able to get this nice graph that quantitatively describes how these interventions in these regions are actually making impact on the ground. Okay, so this is a very cool, I think is a cool. So I wasn't really involved in this one, but this was actually working with a government ministry in Afghanistan, and so they historically didn't have much information on how their crops are doing. So we partnered with them through USAID and helped deliver this web portal for them. And so this is using a lot of Earth Engine algorithms on the back end to do this these quantitative analyses. And so you're able to look at changes in NDVI, what are the trends, where are these trends happening, and this is used by their Ministry of Agriculture, Irrigation, and Livestock to actually understand how their agriculture is improving or where they need to actually intervene in these regions. And so this isn't actually one of our tools. This is working with them through our partner hub. And so they're running this operationally on their end. So nice stories. Any questions on some of the tools or anything? I know that was a lot. If you guys have any questions on what we're doing on the technology side or working with our end users to actually meet their needs, please let me know. Thank you.
At all?
That's all of them. Next.
All right. Yeah, so again, I asked Kale to go through just a quick overview. There are several dozen more. So if there's something that you specifically want or need and we have access to it, we'll give it to you. Come and talk to us afterwards. The next thing we wanted to do is talk about a collaboration that we have with FAO, Alfonso, about Collect Earth and Collect Earth Online. Karis, do you want to talk about this? And then maybe give Alfonso a chance to.
So it was a brief overview of some of the tools that have been developed. Collect Earth Online is one that we get a lot of requests for, and I'm sure a lot of you have worked with Collect Earth, the desktop version. Show of hands, those of you that know what Collect Earth is. So the main challenge that we were facing when we were doing the land cover monitoring system, which we'll talk about next, is when you're working with a lot of different agencies across a number of countries, when you work with the desktop version, you have a lot of Excel files to navigate back and forth and having to manually enter into a shared database. So we wanted to have an online version where people could simultaneously enter data and it was just saved into the same project. So we partnered with FAO and built Collect Earth Online together. And it's an online version of the Collect Earth desktop. So I'll just walk through a couple of the features with this, and then if you have questions, let me know. The link is collect.earth, and when you first open the page, it'll ask you to log in or register. That's an option. And then you'll see a series of institutions. So once you register, you can sign up for an institution, you can ask to join an institution. I think you have to register to collect data, but there are some just open projects as well, so sometimes you can just go in and help collect data with like a citizen mapathon, big citizen science mapathon. And you'll see we have a number of institutions around the world. Once you set up your institution, you have your own institution project page. So this is the one for SERVIR Mekong. And you have a number of users. They can be admin rights, they can be member rights, and a series of projects. And you also see all of the imagery available. We have a lot of default imagery options, but you also have the ability to add WMS feeds. So if you have some imagery set up that's your own private imagery and it's available as a WMS feed, you can link to these feeds through this interface. Once you're ready to go, get your agencies, your citizen stakeholders to collect data, you can set up projects. So a series of things that you can tailor to get a project that suits your needs. You can set the visibility, so who can collect data? Is it, are you collecting information about the landscape that takes some local expertise to understand the difference between orchards and palm oil? Or is it something that's fairly simple where you're just identifying water? And maybe I should back up a step and say, for those of you that don't know what Collect Earth Desktop is, it's a platform to view high-res imagery or moderate resolution imagery, any imagery that's available in Earth Engine and then a number of these feeds, and assign labels to it. So if you went to the session this morning on the accuracy assessment, this is a tool that you can use to collect data for accuracy assessment. For those of you that are running supervised classifications to come up with your land cover products, this is a way you can collect some of the reference data to train those algorithms. For those of you that are doing inventories and you aren't really working with remote sensing Earth observing data yet, you can use this to just do a sample-based inventory and start characterizing the landscape. And I'm sure there's a lot of other uses. So we've set out on a collaborative process to build an architecture that addresses a lot of these, and focused on 4 specific use cases. So I'll show you the overall system, and then we're going to test it on these 4 use cases. So making greenhouse gas reporting a little bit easier, kind of an automated workflow with the land cover mapping process, forest resources assessments, agricultural monitoring, and hydrologic modeling inputs, making sure we have regional data sets across all 5 countries that you can be confident was collected in the same way across political borders. This is the data portal, and there's links in here. We have a shared regional land cover product that we're building, but then we also have these use cases, and we're developing those apps or the tools specific to each of those cases. So there's more information about that.
Hackathon, stickers. If you're interested in this, we're working on this thing. They're stickers.
I also want to note, can you go back one more? So the second GitHub link here, so this is all of our algorithms. So if you see something that you want, while you're going through this, we're posting our algorithms using the Python API to this GitHub page. So if you guys are interested, just please go on there and grab what you need.
It's all Python, like Jupyter and stuff, or?
Well, note taken. It's basically like Python scripts to do these workflows. So as Karis is stepping through what we're doing, we have Python scripts, but we also have a lot of JavaScript code, but it's not as organized.
So Arlie, one of the things we're going to do, again, we're just stepping all over your presentation here. One of the things we're
That's a collaborative process.
It's a collaborative process. So one of the things we're going to do after this hackathon, and we have another meeting in Utah where we're bringing in all the core developers, and we're going to go through basically a code review and clean everything up. Look through this thing and grab whatever you want. If you have improvements, and I know you've been doing this, it's great, we appreciate it. If there's improvements, let us know. But keep your eyes on it and let us, give us your information. When we do that code review and cleanup, we'll make sure it's posted and sent out as well.
Yeah. August, you'll see a lot of action. Cleaning that up. So these are huge challenges. What is our solution? We met with all of the stakeholders in the Mekong and came up with this workflow where we collect a series of biophysical data sets, and if they're not out there available already, we build them ourselves, or sometimes they're already out there. So JRC has a good water product. Do we need to rebuild that? Collecting all of these biophysical layers, or map primitives is what we call them, that contain information about just individual thematic land cover categories. And we recombine those using a rule set that's customizable to come up with a land cover map. Yeah.
How are you dealing with heterogeneous dates in these land cover layers? For instance, you've got forest cover, is that UMD forest cover?
Well, yeah. That's in our system right now, but you could grab any forest cover data set you had.
Yeah, so we're currently working with the UMD folks for them to deliver a regionally calibrated forest cover data set specific for this.
Heterogeneity is probably the best answer. That's part of our hackathon. So when we assemble all of this, we work with each agency building a land cover map and make sure their definitions include clear linkages to each of those primitive products. So here, making sure you're defining your forest cover as, a tree canopy cover threshold, a height, and if you're assigning like a phenology, deciduous, evergreen, a lot of times there's a minimum mapping unit as well. So you come up with those rules on how you're going to define these, and then you create a decision tree. And here the hierarchy is important. The decision tree is built on a series of Boolean statements. So you ask of one biophysical input that's in your definition, is this map product the pixel value greater than or less than some of those thresholds from your definitions? And if it is, it's classified as that land cover type. So the first one is it water? Yes, no. If the answer is no, you trickle on through this decision tree. Because all of the biophysical layers are built independently, how do we propagate uncertainty from each of those individual layers down into our final land cover category? And how do we deal with heterogeneity? The products were built independent of each other. So if we have a mixed pixel, half of it's surface water and half of it's forest, the order in which we ask these questions will impact how that mixed pixel tends to get classified. So it's kind of the benefit of the system, depending on what your objective is. You can arrange things so that if you wanted a map product where you wanted to customize your error of omission or your error of commission based on your needs, you can do that. So an example would be if you have a team and you want to go out and do a restoration in the wilderness and it's expensive to get out there and you need to find a site that meets these certain conditions where you want to go restore it. You want to make sure if you're mapping this, you're mapping it well and you're not going to a site that's a false positive. So here you can adjust this to meet that error structure. On the other side, if you are providing services to communities, you want to make sure that you're not missing communities. So you can adjust the rank here to kind of game the mixed pixels. There's also a potential problem in being able to game the pixels, but because it's a transparent, all the methods are transparent, it's very clear if you are gaming the system. I think this is an interesting discussion topic, and this is kind of part of our hackathon, is how do we develop criteria and guidelines to steer the customization of this and propagate uncertainty throughout?
We
You know, maybe we need to. I'm seeing a lot of blank faces. Can we just do this real quick?
Mhm.
Maybe we can stay right here. Not there. Let's go back to this thing. Here, let's just go through the general framework, right? How it generally works. And Karis, correct me when I get something wrong. All right, so we got a bunch of stakeholders in the room. Most of them don't understand really deep remote sensing. They know what it is, they know how to use it, but there's not a deep understanding of how it physically works. And if you look at the requirements, they have, so imagine having, visualize in your head, you have a person who's a minister of agriculture, another person who's the minister of forestry, and a third person who's the ministry of transportation. Forestry person, ag person, transportation person. So we get them all into a room and we say, what is important for you to map? That's that first one. That's that end user objectives. And the forester is going to say, I want every different type of forest. I want to know their structural diversity, yada, yada, yada. And you ask them, do you care about roads? Yeah, no, not really. Make it all impervious. Do you care about agriculture? I need an agricultural mask. Do you care if it's wheat or tea leaves? Nope, just an agricultural mask, right? And you could assume the same sort of conversations with different sorts of answers for those other two ministers, right? It's like, so then instead of having to build 3 separate products for each of those different ministers, you want to build a system where we could integrate them all together, and then when the Ministry of Forestry is working with the Ministry of Agriculture and they're comparing their maps against each other, for example, that agriculture mask or that forestry mask is consistent between those two folks, right? That's the crux of the problem, right? So when Karis jumps into the typology, right, and that's what this thing was explaining, the typology is really driven by their definitions and their priorities. So how do you build a system that takes that entire conversation and put it into context, right? That's hard. So our approach was like, well, hang on a second. If we can go back and we can dig into their individual definitions, and we can make sure that we're following the fact that anything that they're actually describing needs to be mappable, like we have over here, and we can get a good measure of uncertainty associated with each of those maps, right? So we have a nice, robust system. Some are going to be great. Canopy cover, it's going to be a lot better than canopy height. Canopy height we know is bad. We know there's a lot of uncertainty associated with it. We also know it's a key part of a lot of the policies that they use when they do on-the-ground management. So we can't ignore it because they use it, right, with the uncertainty associated with it. So let's try to figure out how to integrate it, all right? And then I'm going to take you back to here. And so using that approach, just to piggyback on what she said, you have all those layers, and then what we want to focus on is the recombinations, a whole variety of recombinations. When we do the recombination, all this heavy lifting, all that science is already completed, and now what we're focusing on is really understanding how that error propagates, which she understands a lot better than I do, and I hope you can explain it a little bit better than me, and how it cascades into those two different maps. And so, for example, if you have a lot of uncertainty associated with canopy height, when you look at the products that are developed for the Ministry of Forestry, they're going to have a different error structure than they would for the Ministry of Agriculture, because for the Ministry of Agriculture, it's just a forest mask, right? They don't care. And so those are the sorts of things that we need to think about and figure out how to integrate.
No, that's good. And then the other benefit is once you have updated primitive layers, you have a system where you can just trickle this through if you want to replace. So right now, as part of the AST grants, Peter Potapov is updating his tree canopy cover layers and his forest loss layers in the Pantropics. Once these new data sets are available, we can update our shared typology, the regional land cover product, with the improved tree cover layers, and just assign an epic 1 and an epic 2. But you can cascade this process using both data sets. So we're keeping things consistent and still archiving the old methodology.
And are you keeping those like in a metadata? How do you retain all that provenance?
It's on the to-do list.
Yeah. So
Okay, sorry, I didn't.
Yeah, no. So currently the way that we do it, we're going to be completely and totally transparent, which we are because we're on the record. Hello, cameras. Is that each of those algorithms is located in the repository, and so there's different versions associated with each one, and then inside of that code is it's the author, In some situations, like on the UMD system, they don't necessarily use Earth Engine, they use their own system. And that's fine too. The idea with this whole thing is you could bring in your own data for that. That when you pull in that data, it gets pulled into the asset library, again with the metadata attached to that component. But so like right now it's down at the granular level. What we'd like to see is we'd like to see how all those different elements can get pulled into one repository, and more importantly, how it can get pulled into that final map product, so when we distribute a map, you could see where all the different elements are that went into it. That's the to-do list thing that Akil was talking about.
July hackathon. Documentation is big on the list. The second thing about the process is SERVIR's goal is to provide data in an accessible format, but also to build capacity. So this whole process was a collaborative process with a lot of the ministries we work with. So we had a series of 4 workshops where we started developing all of these algorithms. So we had a primitive algorithm building workshop where we taught our partners Earth Engine, and they started doing some research, figuring out some algorithms they could implement in Earth Engine. And for each of the primitives, we developed these white sheets. After the workshop, we have a production series where we continue to develop and build and refine these algorithms. And because you can share all of the data just using the UI interface, we could send out communications with all of our colleagues across the Mekong and have them see, these are the refinements we've made. Take a look at the data, give us some feedback, what do we still need to improve? So we could continue this collaborative process. If they knew JavaScript, they could look at the code editor portion and take some of our functions, improve them, use them. If they didn't, they could look in the map window and give us some just qualitative feedback. The other component they help with is the training data. So we got a lot of reference data that the ministries have already collected. We did a gap assessment on all of the data that was provided, found we had gaps, and set up a series of mapathons using Collect Earth Online with the ministries, university partners, and just started collecting a lot of data for both training and validation, and the validation is on both elements. So each primitive layer, those biophysical layers, we want to have an accuracy assessment on those. And then the final land cover products, that final land cover assembly map, have a validation there. So it's an ambitious reference data collection campaign. These are the points we've collected, and we're continuing to collect more information. This is just an example of the white papers that we'd send out and kind of build out this documentation. This is the data portal. So the nice thing about how the system is being developed is we have the final land cover product that people are going to use for UNFCCC reporting or forest management. But we also have all these intermediate layers that are useful in and of themselves. So users can come here and download the individual thematic building blocks and work with those, or we can work with them to customize the assemblage of all of these products and work with that layer as well. So these are all available on that data portal link. This is the decision tree and the output from the decision tree. So what we do here is for each of these decisions, we run the primitive products through the decision tree and we get one map. All of our primitive layers, we've run a series of times. So most of them are built using random forests. So we'd run a random forest model 10 times, document the mean probability of any pixel being of the land cover of interest. And then we also have a spread about that mean for each pixel. So here we can randomly sample values for each pixel from that distribution. So we run the decision tree once, resample, run it again, resample, run it again. So now we can get some probabilities, which also deals with the question about mixed pixels. So depending on how that sampling scheme filtered out through all of those model runs, we get the probability for one point in time of that pixel being any of those land cover classes, and then it's we have that for the whole year. So we take that and they can set those thresholds to create their final product, and also have some uncertainty associated with their final map products. So here's an example of just a simple three land cover classification system. This is our version 1 shared regional land cover product, and this is available in the data portal. Next steps, we're working with the Hindu Kush Himalaya Hub. So we're expanding the system and improving it, expanding it into Afghanistan, Nepal, Bangladesh, and then Myanmar is covered by both hubs. So working there to continue refining algorithms as a larger group and improving on this. So that's the land cover system. Questions and additional talking points about monitoring.
I know we went through a lot of material, and I thank you guys all for being here. The major upshot is that there's a lot of things happening. There's a lot of need out there for a lot of the stuff that you guys actually do. And there's a lot of space for you guys to actually help engage and participate at any level you like. With that, I encourage you, please we brought some books. I do not want to take them home. Inside of those little books, they describe a lot of the different things that we talked about today. They have a lot of the case studies and that sort of thing. When's the next hackathon thing? If you're interested in that assembly logic component, if that made any sense to you or you got excited about that, first, thank you. And secondly, come to the hackathon session, because that's what we're going to be working on. We still have a little bit of time. Are there any questions? Yeah.
Just a question about the Monte Carlo simulation. As I understand it, you're generating multiple iterations of the random forest to generate uncertainty around the classification.
There's 2 steps. So for each of those primitives, you run the Monte Carlo multiple times to get a measure of uncertainty for a canopy cover or impervious surface or something like that, right? And then once you actually have that tree is fixed, right? So you're not running a random forest on that tree. And that's another thing that was kind of unique. When we worked with the decision makers, it's like, hey, listen, we could optimize those trees to get the optimal class, and the response was, no, I don't want that. I want to be able to define the tree the way I want the tree, with the thresholds where I want them. And so what the Monte Carlo does is it runs multiple iterations of that preset tree on the distributions for each of those nodes, if that makes sense.
I'm wondering if what your follow-up question is also what kind of error are you propagating? And the answer right now is just model stability. But we have an approach to start implementing both model stability and then the error. So taking the error matrix from each of those primitives and calibrating the model uncertainty layers with actual accuracy of the map.
Frank, we stuck a bunch of words in your mouth. What were you going to say?
My actual question was going to be, why are you only running 10 iterations? And I wondered if it's just really expensive or...
No.
So I was trying to get a better understanding of what those 10 iterations was providing, and because it seems like if it was providing this uncertainty that if they're not too expensive, why aren't you running 100?
Well, this is what we were... After this conference, what we got really excited about, I'm kind of clicking through fast here, is using some of those machine learning algorithms instead, right? And then that way we could just leverage, 1,000 iterations. Let's see what happens to develop those primitives. And then when we get into the Monte Carlo simulation, maybe we could transfer something like that over to a different sort of system where we could run through them faster. But like right now, it takes a long time.
I have a question.
Sure.
In the beginning of the talk, you said the Central American SERVIR is no longer online. I remember that being super huge during Mitch. It was the first SERVIR. So what happened, and are you learning from that,
Oh, there were some learning experiences. I'm not. I might look old, but I'm not that old.
So what actually happened? So we work with USAID, and so.
Hey, come here, right here.
Sorry. So we work mostly with USAID, and they're the ones that are working in the region. And so what essentially what happened, to be brutally honest, was there was a shift in focus on USAID. And so basically the hub that we were working with, Catholic, they gained so much capacity, we got ourselves out of a job, which is what we're trying to do, right? We're trying to build the regional capacity, and we're trying to make sure that these geospatial technologies can be sustained in these regions. And so that's essentially what happened.
So what's there now then?
Catholic, they're there. Yeah, that's the institution that we partnered with, and they're doing all their own stuff, so they don't need our help anymore.
Yeah.
In a good way.
Yeah, but there's still partnerships and stuff.
Yeah.
So, Arlie, all those relationships and partnerships and data sharing, all that stuff's still there. But there's just not a hub.
Okay.
Good question.
Here.
Oh, yeah, sorry.
Yeah, some point that I would like to add is that usually, as understood, you are measuring the uncertainty of the model, and you can produce a map of the uncertainty, the probability of each class. But I guess there are new methodologies also to produce maps of the accuracy per pixel. So you have samples, and then you can have the accuracy in all areas. So that would be something that you have data. Again, you can apply this kind of new methods.
Yeah.
Accuracy.
So
That's our next step.
yeah, so the question was, can we produce an accuracy map at a pixel level? And is that on our roadmap? Yeah, that's what we've been trying to figure out how to do properly, publishable type. We're not quite there yet. We're getting there.
And we have a series of mapathons coming up to get a higher density of data that we can run the validation on, with the probabilistic sample design that it's the same.
Yeah, so this whole process would have been much easier if we just build a map for those 3 departments that we talked about. But we would have missed the basic real request or the user requirement thing. So that's why everything's taking just that much longer. That said, we're hoping that once these folks are through the engagement process, they'll be able to pick it up just like Cadillac did. Any other questions? Nothing? Good. Gone. Well, thank you guys. Thank you for your time. I was serious about the books and the pins and the stickers. And then you guys, if we do have a little bit of time left over right now, whoever does want to stay is welcome to, and maybe you guys could talk about the Collect Earth Online thing.
Yeah, I was just gonna say, if you guys have come up with any ideas afterwards, feel free to ask us then. And we'll be, I guess we could sit here until lunch. And if you guys want to get set up on Collect Earth Online, learn more about it, see a demo or what have you, we'll be here.